Safety and innovation are not inherently opposed. The most durable innovation environments, from pharmaceutical regulation to aviation safety, are those where risk is managed transparently, liability is clear, and public trust is maintained. Our task is to construct that environment for AI within our respective organizations. AI safety risks can be generalized across four distinct but interconnected domains. As we proceed through this module, think about AI risks you've considered and under which category or categories they fall. Physical safety. AI systems integrated into critical infrastructure or industries such as autonomous vehicles, medical diagnostics, weapons systems, and the electric grid carry direct potential for physical harm when they malfunction, are misused, or are deliberately compromised. Mental and psychological safety. Conversational AI systems capable of fomenting parasocial bonds, generating highly personalized content, and optimizing for engagement over well being present serious risks of psychological harm. These include dependency formation, exacerbation of anxiety and depression, the onset of what has been deemed AI psychosis, and the use of AI in online harassment and non consensual intimate image generation. Economic safety. AI enabled fraud, deepfake financial manipulation, and data exploitation at scale represent systemic risks to financial integrity. And children's access and protection. Children constitute a uniquely vulnerable class of AI users, yet current age verification frameworks are largely performative. The risks are acute: exposure to harmful content generated or curated by AI, grooming facilitated by conversational agents, AI generated child sexual abuse material, and the developmental impacts of immersive AI companions during formative developmental periods. Organizations developing or deploying AI systems would do well to map them to this four category taxonomy and assign risk owners. Physical risk systems require safety engineering oversight. Psychological risk systems, for example, chatbots, recommendation engines, require a well being and UX review process. Systems involving economic risk should require legal and compliance sign off. Any system accessible to minors requires a child safety assessment before deployment. Beyond direct safety risks, AI's societal footprint is already reshaping foundational domains. Labor and job security, education, environmental impact, and trust in democratic institutions are facing impacts from AI technologies. And in some ways, these areas overlap. Will AI take my job is closely related to will there be any entry level jobs left when I graduate, and what is college preparing me for anyway? Electricity and water consumption needed to power and cool data centers directly ties into policy debates about climate change. Meanwhile, candidates running for office who must answer these questions have to combat AI generated deepfake political ads and other misleading material that erode public trust. Most AI governance roles in most organizations will not require extensive consideration of AI's sociological impacts. However, there are some actions you can take to help mitigate some of the concerns your workforce might be experiencing. For example, establish as a governance principle that AI replaces this task does not mean AI eliminates this role. An organization deciding to embrace AI should be dynamic enough to redesign roles around the capabilities AI augments while retaining human judgment for high stakes, contextual, and relationship intensive tasks. This could even be supported with an official AI workforce transition policy published before deploying AI systems that materially alter job scope. Such a document would clarify which roles may be affected, what retraining or redeployment pathways exist, and how the organization will consult with affected employees. Establish an internal AI skills development program, not just for technical teams, but also for legal, compliance, HR, finance, and others. An organization is not set up for AI success if only engineers understand AI systems. Capability building is a strategic investment. On the environmental side, include AI-related energy consumption and compute expenditure in ESG disclosures. Investors and regulators are increasingly scrutinizing AI's environmental footprint, and it's not unlikely that future regulations will require some form of AI environmental impact reporting. Begin quantifying the carbon cost of your AI stack now before mandatory reporting frameworks compel you to do so under potentially less favorable terms. Finally, audit your procurement and supply chain for AI-driven decision systems that affect your employees or customers, such as automated scheduling, performance scoring, or customer credit assessment. These systems carry employment law, consumer protection, and data privacy risks that are easily missed in standard procurement processes. Getting ahead of the social, regulatory, and reputational risks related to AI's sociological impacts can carry meaningful, if unexpected, benefits to your organization. Now, believe it or not, understanding the risks can actually be easier than understanding why regulating AI is difficult and how those difficulties can be effectively managed. First, there's the pace gap. AI capabilities advance on average every 6 to 12 months. Legislative cycles are far longer, rendering statutory rules obsolete even before implementation. This demands a shift from rules-based to principles-based and outcomes-based regulation, which, as of recording, is a shift regulators have not yet made. Second, there's the opacity problem. As we've discussed, modern deep learning systems are not inherently interpretable. A regulator or court asked to assess whether an AI decision was fair, reasonable, or safe often cannot examine the decision process directly. The black box problem also means that when regulators mandate explainability, there is a risk they are creating rules that are technically impossible to fully comply with. And third, jurisdictional fragmentation. AI systems are developed in one jurisdiction, trained on data from dozens, and deployed globally. The EU AI Act, US executive frameworks, UK pro innovation approach, China's algorithmic recommendation rules, and India's emerging framework take materially divergent approaches. This risks compliance fatigue unless coordinated frameworks become the norm. Now, this list is not exhaustive. What other regulatory and operational challenges can you identify that relate uniquely to AI? The most persistent objection, not just to AI regulation, but to technology regulation generally, is that it will chill innovation. But is this fear rooted in fact? Aviation is safer and larger than it would be without the FAA. Pharmaceuticals are safer and more trusted for having regulatory approval processes. Financial markets function because they have rules. Seems to me the record does not support the proposition that safety regulation is the kiss of death to industry. Regulation done right is like governance done well. It supports innovation and sets up organizations and industries for success. Consider for a moment and jot down your ideas for what would constitute an effective approach to AI safety regulation, and then we'll go over a potential framework. Now for the framework. Let's start with proportionality. Regulatory burden must align to actual risk. A recommendation algorithm for playlists requires very different treatment than an AI system diagnosing cancer or deciding bail applications. As an example, the EU AI Act adopts a risk-based approach with different requirements based on the AI system's inherent risk. Next, outcomes-based, not process-based requirements. Specify what a safe, fair, or transparent AI system must achieve, not how it must be built. This allows technical approaches to evolve while maintaining accountability for results. Next, we have safe harbor for good faith compliance. Provide liability protection for organizations that meet defined governance standards in good faith. This creates positive incentives for governance investment and avoids the paralyzing effect of unlimited liability in novel technological domains. And finally, adaptive governance institutions. Governance institutions must themselves be designed to adapt. Statutory mandates for regular review, mandatory technical expertise on regulatory boards, and standing multi stakeholder advisory bodies ensure governance frameworks remain fit for purpose as the technology evolves. Sunset clauses and automatic review triggers prevent regulatory fossilization. A regulatory framework like this, if adopted by regulators, could easily be leveraged by organizations. For example, a written AI governance policy approved at board level that articulates the organization's principles for responsible AI use, risk tolerance thresholds, and accountability structures with an externally published summary could establish governance credibility with regulators, investors, and customers. Additionally, outcomes based regulation supports outcomes based AI governance. Define what safe, fair, and transparent mean for each AI system in the context of your organization, then build monitoring to verify that those outcomes are being achieved. Now let's return to Panettone Studios. You realize your newest game, which offers AI chatbot interactions, is likely to be very popular among users between the ages of 12 and 16. Luckily, your development team looped you in with enough time before launch that they can design the game's AI features with governance in mind. What questions would you ask these developers, and what would your AI governance recommendations be?